Greetings to my dear students. In the last video, we have seen the Cauchy's theorem and Cauchy's integral formula, and in where we have to apply Cauchy's theorem and in where we need to apply Cauchy's integral formula. And we have seen one solved problem. So in this video, we are going to continue the solving problems, okay? So problem number 2, evaluate integral over C e power z by z dz, where C is the circle, mod z is equal to 1. Okay. Where C is a circle, mod z is equal to 1. In these types of problems, what are the things we need to check first? First, let us write the function f of z. What is the value of f of z? Okay. And then the point where the analytic fails, we need to check whether the point lies inside the circle or outside the circle. If it is lies outside the circle, means we have to use Cauchy's theorem, and if the point lies inside the circle, means we have to use the Cauchy's integral formula. So these are the two things we need to check. Okay, so first look at the function. Look at this one, e power z by z. Okay, so here the denominator part is same as in the Cauchy's integral formula. That is, okay. So instead of z minus z naught, we have z minus 0. Instead of z minus z naught, we have z minus 0. So the z naught is the point z naught where the analytic fails is 0. Okay. So if you substitute the value, if you substitute the value 0 in this place, clearly the analytic fails, isn't it? So therefore, 0 is the point where the analytic fails. Okay. So what are the remaining things? E power z. So we take f of z as e power z. Okay. So we take f of z as e power z. Okay. Next, what we need to do? We have to check whether the point is 0 lies inside the circle or outside the circles. Okay, here what is the circle they have given? It's a circle, mod z is equal to 1. Okay, so mod z equal to 1 means what? It's a circle with the center 0, radius 1. The circle with the center 0, radius 1. So what it will be look like? So we have a straight line here. Okay, so this is 0. Okay, so this is 0. So the circle center 0, radius 1. So here 1, here minus 1. So what could be the circle? It's a circle with the center 0, radius 1 means, so this is our circle. All points inside and on the boundary, this is our circle modulus of z is equal to 1. Okay, here what is the singular point, which means the analytic fails at which point? 0. Clearly 0 lies in the interior of the circle. So here what formula we have to use? Cauchy's integral formula. Cauchy's theorem we couldn't use in this place because the point lies inside the circle. So by Cauchy's integral formula, what we will get? Integral value of this is equal to 2 pi I into f of at that point. Here the point is 0. So we have f of 0. Okay. So this is equal to 2 pi I into, in the place f of z, substitute 0 in the place z. So we have 2 pi I into e power 0. E power 0, the value of e power 0 is 1. So we have 2 pi I. So therefore, integral value of this, integral over c f of z, sorry, e power z by z dz is equal to 2 pi I. Okay. I hope this problem is clear to everyone. So next we move to the next problem, problem number 3. Evaluate 1 by 2 pi I integral over c z square plus 5 by z minus 3 dz, where c is the circle, modulus of z is equal to 4. Okay, so here they have given the function as z square plus 5 by f z minus 3. So compare this function with the Cauchy's integral formula. We get f of z as z square plus 5 because the numerator part contains z minus 3 same as z minus z naught. So the remaining thing is z square plus 5 only. So therefore we can take f of z as z square plus 5. Okay. So next, at which point the analytic fails? The point 3. Okay, in that point 3, the analytic fails. So now we are going to check that whether this point 3 lies inside this circle. So mod z equal to 4 is means what? It's a circle with the center 0 and radius 4. It's a circle with the center 0 and radius 4. Okay. It's a circle with the center 0 and radius 4. So circle with the center 0. So radius 4 means from 0 to 1, 1 radius, 1 to 2, 2 another 1 radius, 2 to 3, another 1 radius, and 4, another 1 radius. So 1, 2, 3, 4. Okay. Similarly, this side we have minus 1, minus 2, and minus 3, minus 4. Okay. Sorry, minus 4. So what will be our circle? This is our circle. Okay. So this is our circle. I should write this side or this side. Okay. Yeah. So clearly the point 3 lies inside the circle. Okay. In other instead of writing the circle, center 0 and radius 4, and drawing the circle, instead of drawing that one, how we can easily check that the point lies inside this one? Okay, you have to substitute the point 3 in this place. Is it okay? Here we have, okay, modulus of z is equal to 4. Okay, so substitute the point 3 in this place. So we have modulus of z. Okay, which modulus of z, which is equal to what? 3. If it is less than or equal to 4 means, less than or equal to 4 means, this one means the point lies inside the circle. Okay, if it is greater than 4 means what? The point lies outside the circle. Instead of drawing the circle, easily you can check whether this point lies inside or outside. What you need to do is, in that place is that you have to substitute that point and you have to check whether this point less than or equal to the radius only. Okay, less than or equal to radius means the point lies inside, greater than the radius means it's outside the circle. So here the point lies inside the circle. So therefore, by Cauchy's integral formula, here we need to use Cauchy's integral formula because the point lies inside the circle. Okay, so by Cauchy's integral formula, what we get? Okay, here they have given 1 by 2 pi I. Okay, 1 by 2 pi I in the integral value only they have asked to find. So by Cauchy's integral formula, yeah, 1 by 2 pi. Okay, this is equal to 1 by 2 pi I integral over C. This is equal to f of z. If they haven't given 1 by 2 pi I means, if they are asked to find only the integral value means, the integral value is equal to 2 pi I into f of z naught. Suppose if they given 1 by 2 pi I means, you need to find the value f of z naught alone. Okay. Okay. So by Cauchy's integral formula, we get 1 by 2 pi I, this value is equal to f of 3. Okay, what is f of z? Z square plus 5. So in that function, instead of z, you have to substitute 3. So what we will get 3 square plus 5, which is equal to 14. So the integral value of this is equal to 14. Okay, so by here we are using Cauchy's integral formula and we evaluate this integral value. Okay, so next problem, evaluate integral over c z by z square minus 1 dz, where c is the circle mod z equal to 2. That is a circle with the center 0 and radius 2. Okay, look at the denominator part. Okay, z by, sorry, the function is z by z square minus 1, but the denominator part is z square minus 1. Okay, yeah, but if you want to, if you need to apply Cauchy's integral formula or Cauchy's theorem, the denominator part must be which form? Some z minus z naught. This form only it should have. Okay, but here we have z square minus 1. It's a quadratic equation, so isn't it? Z minus z naught is a linear equation. It's an equation with the variable z of degree 1, but here we have degree 2. So we have to rechange the z square minus 1 into linear fraction. Okay, so how we can do this? Of course, the partial fraction. Okay, so partial fraction will come into this. So consider, so we are going to do partial fraction for this one. Okay, so consider z by z square minus 1. Z square minus 1 can be written as z minus 1 into z plus 1. A square minus b square can be written as a minus b into a plus b. So same formula we are applying here. Z square minus 1 is equal to z minus 1 into z plus 1. So if they are of degree 1, z minus 1 is a equation of degree 1 and z plus 1 is a equation of degree 1, and that is they are linear fractions. Okay, linear equations, not fractions, linear equations. So if the denominator part contains two linear equations, then the partial fraction, what is the partial fraction? We have rewrite, we have take z by z minus 1 into z plus 1 as, we can rewrite it as some a by z minus 1 plus some b by z plus 1. Okay, now we are taking the LCM. Z minus 1 into z plus 1 will comes in the denominator part. What will be the numerator part? A into z plus 1 plus b into z minus 1. The left hand side we have z by z square minus 1. So z square minus 1 and z minus 1 into these two will get cancelled. So what we will get at the end, z is equal to a into z plus 1 in z plus 1 plus b into z minus 1. So next, what is our aim? We have to find the value of a and b. Okay, so how we will going to find the value of a and b? In order to find the value of a, I don't need the value of b. So when will the b vanish? When we substitute z equal to 1, this will become 0. When we substitute z equal to 1, this term will become 0 and the b term will vanish. So we get only the a term. Similarly, if we need to find the value of b, then we need to vanish the a term. How? Okay, if we substitute z as minus 1, then clearly the a term will vanish. So in similar way, we are finding the value of a and b. Okay, so okay, so when z equal to 1, b will vanish, we get the value of a. When z equal to minus 1, a will vanish and we get the value of b. So we get the value of a as 1 by 2 and the value of b as 1 by 2. So next what we are going to do, we are substituting the value of a and b in this place. Okay, we are going to substitute the value of a and b in this place. Okay, so which is equal to what? Z by z square minus 1. Okay, so therefore z by z square minus 1 is equal to 1 by 2 by z minus 1 plus 1 by 2 by z plus 1. Okay, so now we did the partial fraction for this function. We did the partial fraction and we separate into two functions. Okay, one first function is 1 by 2 by z minus 1. The next function is 1 by 2 by z plus 1. So now we have to take the integral because we need to find the integral value of this one, isn't it? So we are taking integral on both sides. So integral over c z by z square minus 1 dz is equal to integral over this plus integral over this. Okay. Now we consider the first integral. Okay. Now we consider the first integral. This one we are considering. Okay. So here 1 by 2 is a constant value. So we are taking outside. So one integral of 1 by 2 by z minus 1 dz is equal to 1 by 2 into integral over 1 by z minus 1 into dz. Okay. So here what is the value of f of z? Of course, 1. F of z is equal to 1. Here the numerator part is same as z minus z naught. So here, at which point the singular and the analytic fails? At the point 1, the analytic fails. Okay. So now we are going to check the point 1 lies inside the circle or outside the circle. So here, what is our circle first? What is our circle here? Mod z equal to 2. So this is our simple closed curve. So now we are going to check the point lies inside or outside. So our circle is modulus of z is equal to 2. Okay. How will we check that? Instead of z, the point where the analytic fails, we are going to substitute. Okay. So modulus of z will become modulus of 1, which is clearly less than 2, isn't it? It's clearly less than 2, which means the point 1 lies inside the circle. So therefore, in which formula we have to apply? Cauchy's integral formula. So by Cauchy's integral formula, what could be the value of this one? Integral over c 1 by z minus 1 dz is equal to 2 pi I into f of that point, f of 1. Here, what is the value of f of z? 1. It's a constant mapping. So, for every point, it maps to 1 only. So, therefore, f of 1 will become 1 is equal to 2 pi I. Okay. But we just now, for till now, we find the value of this only. Okay. But we need to find the integral value of this one. So this is equal to 1 by 2 into this one. For this part we found. So we have to multiply by 1 by 2. So therefore integral value of this is equal to 1 by 2 into integral value of this. Integral value of this we already found. So 1 by 2 into 2 pi I is equal to pi I. So we find the integral value of first integral. Okay. So next we are taking the second integral. Okay, next we are taking the second integral. What is second integral? This one. Integral over c 1 by 2 divided by z plus 1 into dz. Here, at which point the analytic fails? At the point minus 1. So this rewrite as this we rewrite as 1 by 2 into this part. Which part? We rewrite this as 1 by 2 into, we are taking 1 by 2 outside as it is independent of the variable z. We are taking outside of the integral 1 by 2 into integral over c 1 by z plus 1 into dz. Okay. So here I have written this. Yeah. I have written this. So now we are finding the value of first this one. 1 by z plus 1 dz. So here what is the value of f of z? 1. At which point the singular analytic fails? Minus 1. Whether this minus 1 lies inside the circle? Of course, yes, because our circle is modulus of z equal to 2. When I substitute the value minus 1 in the place of z, we get minus 1. What is the value of my modulus of minus 1? Which is equal to 1, which is less than 2. Okay, so clearly this point lies inside the circle. So therefore, by Cauchy's integral formula, integral over C 1 by z plus 1 dz becomes 2 pi I into f of minus 1. Here the point is minus 1. Since f of z is equal to 1 for all values, we have f of minus 1 as 1 is equal to 2 pi I. So now we have find the value of this one. But we need the value of this one because 1 by 2 integral over C 1 by z plus 1 dz is equal to what? This one equal to 1 integral over C 1 by 2 by z plus 1. This one integral over C, this one. Okay, so in order to find the integral value of this one, what we need to do? We have to multiply by 1 by 2 because this equal to 1 by 2 in the integral over C. So already we found the value of integral over C 1 by z plus 1 dz. So now we are multiplying by 1 by 2. Okay, so we get 1 by 2 into 2 pi I is equal to pi I. So now, okay, actually this is the integral value we need to evaluate. Okay, this is the integral value we need to evaluate. We split this integral into two integrals and found the value one by one. So value of this one is pi I and value of this is also pi I. So if you want to evaluate this integral, what we need to do? We have to add these two integral, the value of these two integral. So pi I plus pi I will become 2 pi I. So therefore, integral value of z by z square minus 1 dz is equal to pi I plus pi I is equal to 2 pi. Okay, so I hope the three problems which I have taken here is clear to you. And thank you, dear students. We will see the remaining problems in the another video. Okay.